Mike Bernhardt for the Exascale Report, and with me today is Rich Bruckner, publisher of Inside HPC. Hey Rich, thanks for joining me.
Well, my pleasure.
I'm really excited about this new format, this new program that we've got going on today, and hope the audience likes it as well. So recently in the Exascale Report, and as reported on Inside HPC, Intel took quite a bit of flack for their announcement of Exascale leadership. A lot of mixed reactions out there, but a lot of negative stuff that really hit them pretty hard. I think it took a couple in the chin on that one. You were at the press briefing at ISC June over in Germany, and what did you think?
Well, I mean, I came away with a much better understanding of what Intel intends to do, and that was their intent. They said, look, we've got an Exascale program, it's funded, it's staffed, and here's the way forward. It's an 8-year project, right? So going out to 2018 and beyond. And frankly, I was kind of surprised by the reaction.
Yeah, and some of it was pretty harsh, as we said. I thought we could use a program like this to kind of dive down into some of this and see if we can't, see what happened there. We found the guy at Intel who really owns responsibility for addressing the issues related to Exascale. His name is Raj Hazra. He's the general manager of high performance computing for Intel, and he owns this Exascale. Now, he's very clear to point out that Exascale is such a huge initiative. It's not any one person, it's not any one group that owns this. It's shared responsibility across hundreds of people, the Exascale research labs, the Intel labs, the product lines, and so forth.
Okay.
Very clear about that.
Yeah.
But when it comes to trying to understand the direction, set the direction, and unfold a strategy that will get a company and get a community to Exascale, he's the guy.
Yeah.
So one of the first questions that I wanted to get out there was related to, they took a couple hits on this interconnect issue. One of the comments that was in the last issue stated that Intel still does not have an interconnect solution, and that's becoming a sore point for them. So I wanted to get right into that one and give Raj a chance to clear that up. And I think he did a really good job of clarifying this for us. So let's take a look at what he had to say.
Okay.
That was actually a very good observation based on what we've said so far. Let me address that issue at a fundamental level of what the fabric means to continuing the march to Exascale. We see the fabric as evolving to be the center point of the system architecture. In many cases it already is that way for the high-end systems. We see the fabric playing a very critical role in the implementation of programming models. We see the fabric being the intelligence of the system in terms of supporting resiliency models, application scaling models, and we see the fabric getting increasingly integrated into silicon components from a pure power performance perspective. So having said that, and our aspirations to provide the best technology for Exascale, it's a given that we are going to concentrate and have been concentrating on fabrics. Let me give you a taste for what we have been doing so far. Fabrics are not new to Intel and our high-performance computing efforts. For a large section of the volume market that ships on Ethernet, we are one of the leaders in 1 gig and 10 gig Ethernet now. But as we get into the highly scalable fabrics of the future, we have active research and prototyping underway in multiple areas of what we would call fabric technology, right from the physicals and into where the electrical to optical transition happens in a very systematic and cost-reduced way, in the microarchitectures of new what we will call NICs and routers, as well as software stacks. What do network APIs of the future look like to support multiple programming models, including the old ones like MPI or the current ones like MPI, as some would say, as well as emerging ones like PGAS. So we have a plethora of R&D, prototyping, and ecosystem engagement on all aspects of those. I think it will become much more clear in the coming months and years as we talk more about the system architecture for these exascale systems and the roles Fabric play, and our intent and our point of view on what the Fabric architecture should look like for people to get a real understanding of both the technology as well as the architecture we bring into the space of fabrics. Needless to say, fabrics are going to be central. There will be no successful exascale system built with a very careful consideration paid to the architecture of the fabric, and we will be there.
Well, that's pretty straightforward, Mike. So what happened after that?
Yeah, you're right. It was pretty straightforward. Well, they got hit on another question. I don't know if you picked up on this, but a few other editors even commented to me. Intel made a comment. They said we could get to exascale without having to change the programming model. Did you pick up on that?
You know, I totally missed that. I mean, I heard a lot of talk about the programming model and that it was going to be a lot easier. And again, that's what I came away with.
Yeah.
So that sounded like good news to me.
Yeah, and I suspect that what happened there was, of course, there's going to be tools and there's going to be new generations of compilers. There's going to be a lot of things that happen over the next, 8 years that will make it easier and maybe will make it possible for us to reuse a lot of code. I don't think it was supposed to come across as such a black and white kind of harsh statement. But again, we asked Raj that question, do you believe we can get to exascale without having to change the programming models? Let's see what he had to say.
Okay.
This is probably one of the more controversial, and controversial as a result of us not communicating potentially as clearly as we should have as to what we meant. I don't think the intent we had was to say that the exascale programming model has been invented and is in use today. So I want to take this opportunity to kind of highlight what is it we really intended to say. What we intended to say was programming model changes are costly to the ecosystem. Not that they can't change or shouldn't change when there is a reason to, but they are costly to an ecosystem. And recognizing the large cost of programming model changes that an entire community has to react to, what we want to do is extract the most out of one programming model, an established programming model, while at the same time we try to enable and incentivize people to get on the next one that's going to continue the progression of capability. So in that spirit, when we say people don't have to change programming models, our intent really is avoiding costly detours. To the extent that we can take the MPI style of programming that's well established today and continue to scale it even on future exascale architectures, we believe there is a big and broad and important community of users that will benefit from that, even if they don't adopt a new programming model that gets to even higher levels of performance, scalability, and resiliency. That said, to continue to keep the very top of the envelope or the edge of the envelope going, we do see need to invent and make what I would call democratize newer programming models like PGAS into the community. So I want to be very clear. Our statement was not that programming models would never have to change, but our statement was we would like to have a consistent, well understood, and well used programming model extend as far as possible as it can, while we collectively set course for the next generation of programming models to be embraced and adopted. And for exascale systems, they can't just be superb on the new programming model. They also have to deliver the goods for people that are still using the yesterday's programming models. Our view of exascale systems, therefore, is they will support new programming models, yet they will also do very well and support MPI-style current programming models better than systems of today.
Is that a programming model adaptation? Is that a toolkit that you envision maybe in the future?
So if you go back to the canonical definition of a programming model, and being an old software hack myself, I can see this in spades. is you have to ask yourself, a programming model is an abstraction of a system, right? From a programmer's point of view that wants to get a task done. So we run into programming models. This word has probably become overloaded in multiple areas. Some people will say the node level programming models around being able to use cores and caches and threads is a programming model, and probably is for some level of abstraction if that's the part of the system you're looking at. Some people would say how you compose or decompose a job across a distributed system, and MPI is one example, right, is a programming model. You know, what happens literally on the node is less my concern, but I want to see how a job is decomposed and run across a big system, and that's the abstraction I'm looking for. Some people look at it as a combination of that and what is my view of memory, right, which is where some of the global addressable programming models get built. So for us, programming models is this composition of multiple levels of parallelism as architectures and supporting layers on top of that architecture become more parallel sensitive or parallel enabling, right? So what do we do on the node architecture itself? What do we do on the system architecture or the platform architecture? What do we do in the software architecture, right up to how you express parallelism through new languages? All of that is part of what we think of as a programming model agenda, right? And so for us, as I said previously, for us, as those are understood in a particular generation, what we want to understand is where should changes happen and how best to seamlessly introduce those changes to continue to keep an entire community moving forward, as opposed to splinter it into special, you know, niches, if you will, or segments that can only use a particular programming model.
It sounds pretty good, doesn't it, Rich? I mean, the guy is coming across, he's warm, he's sincere. I like the humble approach that's coming out of this. It's a lot different than what people were saying about Intel in terms of the reactions last time.
Sure, this stuff isn't defined. These are the fledgling stages of a big long-term project.
Exactly, exactly. So, you know, the question that I had on my mind that came out of that announcement is, you know, obviously Exascale is a huge systems level approach.
Yes, yes.
And so why should Intel be able to assume or presume that they'll be in a position of Exascale leadership? You know? So let's see what Raj has to say about that.
Okay.
A very interesting question. I can see the genesis of that question based on the comments we made. But again, let me clarify. It is absolutely true that building a real Exascale system, a usable Exascale system, a cost-effective Exascale system, is a system-level endeavor. It starts with a system architecture and a software architecture that have to be co-designed together. I mean, that's the whole definition of co-design. From our perspective, we are not, even though our products look like components into systems, the increasing level of integration into the components and then the increasing linkage into the software that runs on that hardware makes us a systems company today, even whether our business model is around selling systems or not. I mean, the analogy I use is a company that makes SoCs but doesn't make the end phone. Are they a systems company or not? Well, it's a system on a chip. In the HPC space, certainly in the Exascale space, both at the node level and at the system level of understanding how all of the components in the system, the nodes, the storage, the networking, the communication interact, that is a system level definition. What we decide to sell as products into it is somewhat of a related but orthogonal question. Our OEMs are partners that actually, whose business model is to sell the system, to build and sell and maintain the system, to provide the software, see this as a good partnership opportunity with us. And we see it the same way too. It's a value building opportunity where we work together in defining the system and architecture. They have a better understanding now of what we intend to do in our components, what the progression is over time, driven by integration. and Moore's law, and we have a better understanding of their requirements, their business models, their need to differentiate. And it is a good synergistic approach to trying and continue a model by which we can both be successful at the same time giving the users what they really need.
So Mike, I guess this brings out, okay, the programming model, and that really just paved the way for them to talk about Mike, okay? Yeah. They had announced Mike the year before Knight's Ferry, right, at ISC. This was the year that really they showed the goods, right? Yes, they had prototype hardware, they had showed people like CERN, institutions like that had machines running code, showing how it all scaled. So what did you ask them about Mike?
So Raj, clearly Intel's positioning the Mike architecture as the path to exascale, but Mike is not a mainstream architecture. Do you foresee Mike as becoming a mainstream architecture, or will exascale computing in the future be relegated to non-standard high-end architectures?
Great question. There's two parts to the question that have assumptions, and let me clarify those assumptions. I think your first statement was that we are basing our exascale on Mike. I want to make sure we understand what we mean by that. If you take a look at what we've said, what Mike is, it's many integrated cores, right? So it's clearly a statement about an architectural approach that has high level of parallelism supported by large number of compute cores. And of course, everything that goes around it, feeding the cores with memory, I/O. And what you've seen in our nearer term announcements on what the immediate set of products might be, they're all x86 cores. It's well understood what I would call evolutionary technology. Great products built on years of investment, but it's kind of capping up what we've been investing in so far. When we say Mike is the workhorse that is going to get us to exascale, I don't want people to think it's Mike as we see it in the next or two product incarnations, and have preconceived notions of whether the microarchitecture looks a particular way, the memory architecture looks a particular way, the I/O architecture looks a particular way, that you see it described in the next immediate set of products in the future. You should think of it as a breakaway from our traditional multi-core products into very efficient and increasingly power efficient, highly parallel compute architectures, right? So that's one. So Mike as a pathway to exascale is a statement that we are going to have to get to exascale with high degrees of parallelism, and there will be large inflection points even on that journey, whether it's a new microarchitecture, whether it's a whole new memory architecture, whether it's a whole new I/O architecture, right? A whole new execution model, a whole new, resiliency domain. We don't know which of those. That's what research is about. What of those has to change and when? But our statement that we are going to do all of that research in partnership with governments, our partners, and other interested stakeholders, and find the right instantiations of innovations to put in that general architectural class over time. My whole point of saying this was, don't assume that what we are saying is the Mike of 2018 is simply the Mike of 2012 on steroids. It won't be, right? The second was I think there was an assumption in the question that Mike is not a mainstream product. So that's interesting because, and just to let you know why I'm smiling, it's because we've had this question and debate internally as well. I guess it comes back to what is mainstream, right? If you look at the early shaping of a market, right, volumes don't make something look mainstream. Initially, as the world transitions from single core to multi-core, now to many core, and we keep going up the parallelism pathway, mountain, if you will, some will say, the early generations look small in volume because these get adopted. The adoption funnel has just started. So you could say, certainly from a volume perspective, it doesn't look mainstream, and that's what the genesis of the question is. The other way you can look at it is, how much are you investing to build this capability and sustain it over time? Certainly from an Intel perspective, by that measure, it is absolutely mainstream. The number of people, both in hardware and software, working on the many integrated core architecture makes it absolutely equal in class to our Xeon class of products. Right? We have probably the most significant software and architecture in terms of design team investment in Mike and a product line around Mike than, say, our Pentium Pro decision to get into servers, right? So again, from the investment, which in some sense is a measure of a company's intent and faith in the promise of something, it's absolutely mainstream. It's not a side experiment. It is not a small, let's go do it and see if it works or not. It is the size of investment that is absolutely material to any R&D as a percentage of revenue measurement. And certainly in terms of energy and the talent inside the company that we've gotten together to put on it, it is about as mainstream as you can get.
So Mike, I guess, that's the first question I had when I heard about Mike was, where's the volume going to come from? That's going to bring the cost down if it's just an HPC processor.
Yeah.
But moving on, I think, we've talked about programming models. We've talked about many core, but we haven't talked about the power issue. To get to a 20 megawatt machine, it's like 1,000x improvement that they need to get to. So did you guys touch on that at all?
Well, in a way, yes. What I tried to do is just kind of keep this grounded. I didn't want to talk about a lot of the issues that are out there, but I did ask Raj, when it comes to topic of Exascale and Intel, what are some of the things that you would like people to remember or people to associate Intel with? And he gave a pretty good response to it, I have to say.
Okay. I think the first thing when we talk about Intel and Exascale, people should remember that Intel's a company built on innovation and doing what is generally thought of as very hard, if not impossible. I mean, we've driven Moore's Law further than I think sometimes even Gordon would admit, although I haven't asked him this question. And Exascale is ripe for that kind of an attitude and a capability, right? If you look at just the power performance improvements that have to happen in order to get to an Exascale system somewhere in the 20 megawatt range, that is just stunning in terms of where we are today and the amount of effort and research that has to go in. So innovation has to happen, not only power performance and resiliency and software models in applications and system software. And people should assume that Intel isn't just working on CPUs. People should know that we are looking at it as a system problem and are deeply invested in many areas of research in this problem space. The second thing they should assume when they think about Intel and Exascale is partnership. Intel, and Kirk said this at ISC, is we think we have a very important role to play, but by no means do we think that we are our efforts alone will get an ecosystem to Exascale. We have to partner with folks that have the right competencies in different areas. For instance, we are not a memory company per se. I mean, there's lots of memory in our processors and components, but we're not a memory company. We could partner with the best of the breed in memories. Same thing in software space. Same thing in very interesting problems around power packaging and cooling. Right? We could partner. So they should think of it as opposed to a very vertical closed approach, a partnership-based approach, bringing the right competencies, and by the way, that includes academia as well. Partnership-based approach to get the best minds working on the biggest problems in Exascale. And the third thing they should think about as a follow-on to partnership is ecosystem. We are not consistent with our business model and success, we are not about building one exascale machine or a special class of machines that only a very few number of customers can buy. We're an exascale because we actually see the high end of the market as a viable market. But more importantly, we see the right way to reach exascale also have tremendous trickle-down benefits in other parts of the more commercial business. And the phrase right ways to get to exascale is important. When people think of Intel and think of partnership, ecosystem, and innovation, all of that happens in a business context for us where we want to improve the rate and reach of technology, not just in HPC or exascale, but in the broader space of connected intelligent systems as a result of this work, right? And actually have a viable business model for us and others to continue to invest in and reap the benefits from. Very different than a vertical approach and a very targeted approach to satisfying a market with exactly what it needs without considering these other broader business and ecosystem impacts.
So Mike, I guess that brings out the big point, right? This is about business. If Intel develops an exascale machine, the rest of their company will benefit from all the technology trickle down, right?
Yeah, yeah.
So recently we saw a big event here with IBM pulling out of Blue Waters, a very difficult project to build. It wasn't economically viable for the company. And this is just 1% of an exascale system, right? 1,000.
Good point.
All right. So did you ask Raj anything about that event and then what would happen if they face similar kind of circumstances?
Yeah, actually we did. And before I got to say, I like this guy. I like these responses they're coming across to me as very genuine, very heartfelt. I think Intel really is trying to make some big strides here to take a really good high road to this thing. I have to say, I can see where some of the confusion came from. As I said, I was there, and I think on a couple of the questions where the community reacted so negatively, I can see it was some mode of a miscommunication. So I think that just stepping up like this and responding and just trying to clarify, I think is a really good thing. It's a good thing for all of us. Now, regarding IBM, NCSA, Blue Waters, yeah, I did bring that up, and basically in the context of, isn't there just as likely a chance that Intel would have to walk away from exascale at some point because of funding, because of it not being something that could contribute to a future business model? And Raj addressed that. So let's see what he had to say on that one.
Okay.
So Raj, we recently had in the news something I think that's not so great for the HPC community with IBM having to pull out of Blue Waters. They were certainly committed to Blue Waters. We heard Kirk say very clearly that Intel's committed to exascale. Could the same thing happen to Intel? Could Intel have to walk away from exascale because of funding issues?
So I can't speculate and comment on IBM's decisions there. With respect to our commitment, I think Kirk was very clear that our commitment is one of our intent in an ecosystem, and other people, including people who will use it, including people who also have to contribute to it, either with talent, technology, or funding, also have to play their parts. What we said is, clearly this is bigger than one company, and we need all of us to do our parts. Our commitment was to do our part, and we will do that. Whether we can reach exascale or not will depend on this community solving the technical problems, this community working together, and our commitment is to do our part.
Okay. All right, I saved the hardest question for last.
Okay.
A number of the comments and the community feedback in that last issue were clearly voicing frustration at some level at Intel's market relations was called out, whatever people interpret that to be. Do you feel Intel has the lion's share of loyalty and support from the HPC community at this point, or what do you think is going on out there?
That was an interesting, actually was probably one of the most informative realizations I had from reading the report, while there were lots of good questions at programming model fabrics and those kinds of specific areas, the general education I got from what you term as market relations and our need to actually be better at explaining our point of view, the need for us to actually be more connected, more frequently connected, and the need for us to listen better, all came through very clearly. And for that, I think I not only thank the people that gave us that feedback, but I also thank the opportunity to actually get it. It is clearly an area that we will need to do better as we work through complex issues of things like Exascale, which has its technical challenges, its business challenges, large number of players, and we will have to explain our position more credibly and more clearly going forward. We are absolutely committed to doing that. We sometimes have some constraints, as some of the research we, for multiple reasons, cannot talk about in public as much as we'd want to. And sometimes we just probably don't make the optimal decisions of when to talk about something and how broadly to talk about it. But it is absolutely an area for me personally to focus the business on partnering better with the community, right? Partnering is not just a technical partnering for us anymore, it's partnering with the entire community in order to make sure we're on the same page, that our page is being understood, that we understand other people's pages, and specifically actually to understand feedback and react and adapt and improve ourselves as a result of it.
So Mike, I guess Intel kind of took one on the chin. They came back, and I think they did a great job of clearing things up and saying, hey, we're going to work with the community going forward. What do you think?
I would agree, Rich. I think this is very commendable. It's well articulated. It's got the right attitude, I think, the right kind of tone, good content here as well. And I think it should go a long way in helping them with community relations. So, thumbs up for Intel on this one.
Terrific, terrific. Well, thanks for having me on today.
Hey, this has been fun. Let's do more of these.
Okay.
All right. For the Exascale Report, Rich Bruckner, Inside HPC, I'm Mike Bernhardt. Join us next time.